2 pi. And then what's the period for tangent? Is that a hand or just elevating?
Oh, no, that's
Yeah.
Sorry.
You're good. Okay, so we got pi. Alrighty. So here, let's go ahead and jump into our first example. Okay, so here I have 3 sine x minus 2 equals 5 sine x minus 1. All right, and step 1 is isolate the trig function. So I need to get sine all by itself. So that's easy to do. We'll subtract 3 sine of x from both sides. So we get -2 equals 2 sine x minus 1. Add 1 to both sides. So we get -1 equals 2 sine x. So then sine x equals -1/2. So our sine is all by itself, and then we have what it equals on the other side. So we are isolated. Okay, and this is where we ask for what values of x, so what values of x does sine of x equal -1/2? This is where your unit circle is going to come into play. You do need to know those unit circle values. Okay, so I know that at pi over 3, no, that's not right. At pi over 6, no, that's not right either. Dang it, it's radical 3 over 2. Yeah, so at pi over 6, sine of x is equal to +1/2, correct? And then we want to use this right here, this little thing where all students take calculus. So in the first quadrant, sine is positive, and in the second quadrant, sine is positive. But in the third and fourth quadrant, we would have -1/2 at the pi over 6 as a reference angle. So in this quadrant, so quadrant 2 and quadrant 3, or I'm sorry, 3 and 4, is where sine of x would equal 1/2. So what is the reference angle in the third quadrant for pi over 6? One more than the denominator. So it goes pi over 6, 5 pi over 6. What's this one? Yeah. 7 pi over 6. So 7 pi over 6, it's -1/2. Sorry, my dress got ripped, so I just need to get my spears. Okay, and then what about in the fourth quadrant? What is this one? We got 7 pi over 6 and yeah. Yep, 11 pi over 6. Okay, so if we were to plug in and say sine of 7 pi over 6, we get -1/2. This stupid thing. And then if we were to plug in sine of 11 pi over 6, we would also get -1/2. Okay? All right, so then we want to add the period now. So we're going to add 2 pi n to each of these. And that n is how many times around it goes. So if we have a 0, it's the first time around. If we had a 1, it's already gone around one time. We're going around again, 2, and so on and so forth, because we can go around that circle as many times as we want to. Okay, so this right here is our final answer. We've already solved for the variable and all that good stuff. just to clean up our answer, we can write it as x equals 7 pi over 6 plus 2 pi n, and x equals 11 pi over 6 plus 2 pi n. All right, what questions do you have over that? Yeah, Jenna?
So do we just not add the 2 pi together with the fraction?
No, we are actually going to talk about it in the next one where we have an interval. For this one, we don't want to add because it's just, we don't need to because it's not asking for like specific values. This one asks for specific values, so we do have to. But when you write your answer, just remember to put that 2 pi in. Because basically what it's saying is, it's asking where sine of x is equal to -1/2. And it's equal to -1/2 here and here, but it's also equal at what? 19 pi over 6. And would that be 23 pi, or yeah, 23 pi over 6, and so on and so forth. So it keeps going. We can still have more values. Okay, let's go on to the next one here. So do you see how it has tangent of 3x equals 1? And it's basically isolated. I say basically because we have just tangent, but then that 3 in there makes it not. So this is one where we have to replace 3x with theta. So we're going to write it out as tangent of theta equals 1. And we're going to pay attention to this interval on the last step. So just keep it in your back pocket. We'll come back to that. Okay, so now we have isolated, now that we have tangent of theta equals 1. So now I want to ask for what values of theta does tangent of theta equal 1? So tangent, we have a positive 1. Tangent is positive in which two quadrants? Anna? 1 and 3. Okay, so in quadrant 1 and quadrant 3, tangent is positive. Okay, so we want to write that out. So we're going to say, oh, I'm sorry. Hold up. We got to say what those values are. So in the first quadrant, where's tangent equal to 1? Yeah, pi over 4. And then in the third quadrant, it's 5 pi over 4. So theta is equal to pi over 4 and 5 pi over 4. Now, before we move on, I want to show you something. What's the period for tangent? Pi. So if I add pi to pi over 4, what do I get? Multiply by 4 over 4. So I have pi over 4 plus 4 pi over 4. What is that? 5 pi over 4. So it's not really necessary that we show that second value because of what the period is, okay? So we're going to ignore that second one because we're going to catch it later. Does that make sense? We'll have it in our final answer. Okay, so, all right, now we need to go back in and replace this with the 3x. So let's add our plus pi over here. So we're going to say that 3x, going back to replacing theta, 3x equals pi over 4 plus pi n. Now it's really important we add the period right now when we replace this. Okay, and here's why. because we're going to divide both sides by 3, so we can get x all by itself. So I get x equals pi over 12 plus pi over 3n. Okay, so if you remember from chapter 4, I think chapter 4, this 3x here, that's making it go 3 times as fast. Yeah, 3 times as fast. So the period is a third of what it was before. So now it's shortened in the span of time. So we are getting tangent to equal 1 way more than we would if it were just its normal period. Okay, so we've solved for the variable, but we need to go between 0 and 2 pi. So this is where the n kind of comes in. So what we're going to do is we're just going to keep adding pi over 3 until we get over 2 pi. So we're going to say n equals 0, n equals 1, n equals 2. We'll start with 4 and we need to go from there. Okay, so at n equals 0, if I plug 0 into here, what do I get? Pi over 12 plus pi over 3 times 0. Yeah, pi over 12. Okay, then what about pi over 12 plus pi over 3 times 1? You can rewrite this, so this is pi over 12 plus 4 pi over 12 then. So if I add 1 4 pi over 12, what am I getting? Yes? Yeah.
5 pi over 12.
5 pi over 12. At n equals 2, so if we do 8 pi over 12 plus pi over 12. What's 5 plus 4, guys? Wake up. Yeah.
9 pi over 12.
9 pi over 12. Then we keep going up, so we get 13 pi over 12. 17, no, that's all right. Yeah, 17 pi over 12. 21 pi over 12. 25 pi over 12. Now, 25 pi over 12 is greater than 2 pi. So this one goes away because it's greater than 2 pi. All right, so these are all of the answers between 0 and 2 pi, where if we were to plug those into tangent of 3x, we would get a 1 out. Does that make sense? So on the ones where it asks you for an interval, you have to list all of them between that interval. We don't do it super often, but it does happen from time to time. Okay, let's look at this next one here. Okay, so I have sine of x over 2 equals radical 3 over 2. Okay, this is another one where I have to replace that x over 2 with theta. So I'm going to write this out as sine of theta equals radical 3 over 2, where theta is equal to x over 2. Is there a question?
Why can't you just times the 2 on both sides?
Because if you were to times the 2 on both sides, what you're actually doing is multiplying the outside by 2. Because if you remember from our double angle formula, we'll just say sine of 2 theta. Sine of 2 theta isn't equal to 2 sine of theta. It's equal to sine of 2 sine of theta cosine of theta from that double angle formula. All right, so that was a good question. All right, so we've replaced we've replaced x over 2 with theta. And so we have sine of theta equals radical 3 over 2. So we're good there. So we ask for what values of theta does sine of theta equal radical 3 over 2? Take a second, go ahead and write out what theta would equal, and don't forget to add your period. So do these 2 steps on your own. You can talk to people sitting around you, all that jazz. You also might want to get your unit circle out for the time being. All right, so where is theta equal to radical 3? I'm sorry, when is sine of theta equal to radical 3 over 2? When theta is equal to what? Yes. Pi over 3. Is it only equal there? Where else? 2 pi over 3. Very good. Okay, and then we also want to add our period, which is 2 pi. Very good. We'll plop that in on there as well. All right, so we're going to go back and set up our 2 equations. So I'm going to replace this back. So I have x over 2 equals pi over 3 plus 2 pi n, and x over 2 equals 2 pi over 3 plus 2 pi n. And then I'm going to solve. So I'm going to multiply both sides by 2. So I get x equals 2 pi over 3 plus 4 pi n. And x equals 4 pi over 3 plus 4 pi n. Now, we need to list the values between 0 and 2 pi. If I add 4 pi to 2 pi over 3, am I going to be between 0 and 2 pi? No. If I add 4 pi to 4 pi over 3, am I going to be between 0 and 2 pi? No. So when we list all the values between 0 and 2 pi, it's just going to be 2 pi over 3 and 4 pi over 3. It is often that you luck out like that and don't have to add like we did the last one. Cool? Are we feeling okay? All right, I want you to try this next one on your own. I think it's actually Yeah. Okay, so do the next one on your own, and then we'll come back together in just a moment. Put that phone away.
Wait, do I have to get the 2 away?
Yeah, the same one.
Yeah. Okay, I already not catching this. My second grade sister. Probably, yeah. We have to get the 2 away from the side.
There's not many variations, so if you are gonna. Yes, we always want to add it to try it, and how we use it is dependent on whether we have a circle or.
Oh, yeah, that's it.
All right, take another like 30 seconds with that. I think a lot of you guys are close.
I mean, if you just.
Okay, let's come back together, guys. So, what do I need to do first? Isolate. So we'll subtract 3 sine of x from both sides. So I get 2 sine x equals radical 3. Divide by 2. And sine of x is equal to radical 3 over 2. Okay, then what do I have to do? What? That's all you got? Do I need to replace x with theta? No, why not? Yeah, because it's already isolated. We don't need to replace. There's no point in that. Okay, so what else do I have to do now? Find those values. So for what values of x does sine of x equal radical 3 over 2? Emily? Good. Pi over 3 and 2 pi over 3. And then what else do I have to do? Add the period. Very good. Because I don't have an interval, all right, no interval. This is it. This is our final answer. We added that 2 pi in. Now, someone asked a very good question. They said, do you have to add the period every time? And the answer is yes, but depending on the problem, it's going to change how we use it. So if we have an interval, we have to plug in n. If we don't have an interval, then we just write the plus 2 pi n. And if the interval is too, if we use the interval, that's not right. That's not what I'm saying. If we have an interval and the value, like 2 pi, is too big, then we don't even end up adding it at all. We added it, but then we ignore it, pretty much. Okay? All right. Let's go ahead and try this one here. I'll give you about, I don't know, 2.5 minutes.
No, I'm not done. I need to and then the only thing we're doing on this all the rest. And then, so then we would so it would be, yeah, the two, so you would divide that to, so then the fraction.
I think the last one is over 2. I think it was like 5 or 3.
And then
Pretty much you do one.
So then we have to kind of yes, we were yeah. So like
All right, guys, let's bring it back. If you're still working, that's fine. You finish it up. Ignore me. Okay, so what are we going to do step 1? Who's saying that? Is that Taylor talking? No? I heard someone talking. Sorry, I can't figure out who's saying it. What do we do first, y'all? Make it theta. So we are going to have tangent of theta equals radical 3. Don't forget to write off to the side that theta is equal to 2x. I'm sure you did. Okay. So when is tangent of theta equal to radical 3? Ty?
5 over 3, 4 pi over 3.
Pi over 3 and 4 pi over 3. Very good. Okay. Then we want to add the period. Then what? We're going to take that 2x and put it back. So we have 2x equals pi over 3 plus pi n, and I forgot my n on this little bit. And then 2x equals 4 pi over 3 plus pi n. For those of you that ignore 4 pi over 3, that's fine. I'm just going to hit this point home, okay? So we're going to divide by 2 on both sides. So I have x equals pi over 6 plus pi over 2n. And then x equals 2 pi over 3 plus pi over 2n. We want all the answers between 0 and 2 pi. I'm going to go ahead and rewrite these so that I have common denominators so it's easy to add. So pi over 6 plus 3 pi over 6n and 4 pi. We'll just keep it as 4 pi over 6. I just changed it to plus 3 pi over 6n. Okay, so let's start with the values for pi over 6 between 0 and 2 pi. So the first one is going to be pi over 6. Then what? We add n to that, Emily? 4 pi over 6. Then what? Jenna? Beautiful. Then what? Jenna? 10 pi over 6. And then the next one is 13 pi over 6. Is that between 0 and 2 pi? No. All right, we'll do the same thing for 4 pi over 6. So I get x equals 4 pi over 6, 7 pi over 6, 10 pi over 6. Notice that these are shared with these ones. That's why we ignore these ones. So these are repeats. So we could have initially ignored four pi over 6 earlier, or 4 pi over 3, or whatever you want to say. Okay, so these right here are answers between 0 and 2 pi, where if we plugged them into our initial equation, we would get radical 3. Cool, you guys have about 5 minutes left. I'm going to go ahead and write your assignment up here. Now, if you are to look at the calendar, hold up, let me write this down first, and then I'll talk about that. So your homework's on page 674, 1, 7, 15, 19, 73. Okay? Come with questions on Monday. The Ed puzzle tonight also does not have sound. So you can watch it if you really want to without sound. Or you can just wait and we're going to do them in class on Monday just like we did today. Okay? Cool? All right.